Okay, let's see. Hello guys. I am going to go over U substitution, and in these we are going to have trig functions. So if you look at this, we want to integrate 90x squared multiplied by sine of 2 plus 6x cubed dx. So if we look at this, we think of it as a composition. Our u is going to be that inside function 2 plus 6x cubed. So I say let u equal this. Then our du is the derivative, so that's going to be 18x squared dx. Now if you notice over here, there's not an 18, but there is a 90. So we can ask ourselves, well, what gives us the 18? It would be 5 times the 90. So 5, and then 5 times the du would give us the 90x squared dx. So the 5 and the du are taken care of. And then sine u. Well, now we can integrate sine. If you remember the other day, we wrote down the antiderivatives. And so we know the antiderivative of sine is negative cosine. So we have a negative 5 cosine u plus c. Now, substitution. We need to go back in and replace the u with what u is. So that's going to become negative 5 times cosine of 2 plus 6x cubed plus c. So we're still doing this just like we have been. However, you have the trig functions. Okay, so now looking at number 6, we have secant. We're going to integrate the secant of 1 minus z multiplied by tangent 1 minus z. So if we're looking here, this is 1 minus z is our u. So we have secant u, tangent u, and then if you notice when you take the derivative, that's going to be negative 1 dz, because the derivative of negative z is negative 1. Now there is no negative 1, so we have to pull that in. So this is what our new antiderivative looks like when we put our u's. So this is the antiderivative of secant tangent. So if you go back and you look at our notes of what the antiderivative of secant tangent is, it is secant. So we have negative secant u plus c. Now remember, the whole idea here is substitution. So we want to take our u and substitute it back into the statement. So negative secant of 1 minus z plus c. So again, you're still pulling out your u. That's the inside function. You're taking the derivative of the inside function. Now, the idea is this u and du should become whatever's here. However, you might have to manipulate it a little bit. Like that negative 1 wasn't there, so you have to account for it. In the last one, we had a 90 and we only had an 18. So we had to ask ourselves, well, what 18 times what could make that 90? Because I can pull out something that I'm multiplying by. All right. Number 7, if you look here, we have 15t to the negative 2 minus 5t times cosine 6t to the negative 1 plus t squared dt. All right, so if I'm looking at the inside function, the cosine has, something on the inside, the composition, the inside function there is 6t to the negative 1 plus t squared. Once we identify our u, we want to take the derivative to find our du. So looking at that, we have to get in the mindset of derivative, and we know that's going to become negative 6t to the negative 2 plus 2t dt. So now, when I look at this, I'm like, whoa, that's not what we have. However, you can kind of already see what I pulled out. But you look at it and you have to ask yourself, well, how can I get this negative 6 to be a 15? How can I get this 2 to be a negative 5? So if I look at negative 5 times what? Like, what can I multiply this negative 5? What can I multiply the 2 by to get the negative 5? Sorry, what can I multiply the 2 by to get the negative 5? So, 2 times the negative 5 halves. And then if I look at this, 6 times negative 5 halves becomes positive 30 over 2, which is positive 15. And so I did kind of show that here if I took out the negative 2. And then if I was to multiply the inside by 5, I'd pull the 5 out. However, you don't have to do all that. You could just look from here and see, well, what could I multiply that by? So now I have negative sine u plus c. And then replace my u. Some just reminders here is don't forget your plus c. And also, don't forget to plug back in for u. Substitute. All right, so number 8. This we had an e. Exponential function. We have 7y minus 2y cubed. Now, you might look at this and you're like, I don't know which one's the inside function. Well, when you have that e, we're used to e to the x. Well, this isn't e to the x. There's something that's replaced that x. So, that's the composition piece. That's the inside function. So, our u is y to the 4th minus 7y squared. Okay, then we take the derivative of u. So that'll become 4y cubed minus 14y. Now I don't have any of that right here. But I do have a y cubed and I do have a y. So if I have this 14y cubed minus this 4y cubed minus 14y. Now I ask myself, what would I do to this du to end up here? And you might be like, oh, you just divide out a negative 2. But that's the same as multiplying by negative 1/2. So we pull out the negative 1/2. And just to kind of reiterate, the negative 1/2 du is what makes up this 7y minus 2y cubed dy, and the negative 1/2 is what makes up the du. And then e to the u is the u portion, is e to the u. So, the antiderivative of e is itself plus c. All right? Then, substitute back in for the u. All right? Number 9. Now, this one is a little different. We have it's written as a fraction. And so when we want to look at this, I look at the denominator here, and that is a higher exponent. So I should know if I choose that to be my u, then when I take the derivative of it, I'm likely to get something in the terms, you know how the numerator has 4w's to the first power? We're more likely to get that. So I'm going to use my u, the denominator is my u, and then take the derivative. So the derivative will become 8w plus 6 dw. So I don't have an 8w plus 6 here, but I can easily say 4 times 2 gives me that 8. So if I pull out a 1/2, I'm left with 1 over u du. So now you might be like, oh, I don't know what to do here. Well, if you look back at our notes where we did trig, exponential, and logs, you will see that we get the integral of 1 over u is the natural log of u. And then we substitute in for u to get 1/2 natural log of 4w plus 3 plus c. So with these that we've been doing, you might have to reference back to our trig identities, our trig integrals, our logs, our exponential functions, and that's okay. All right, number 10. Here we have cosine of 3t minus t squared sine 3t minus t cubed, and all of that is to the 5th. So here I'm going to choose the sine 3t minus t cubed. No, it's not all to the 5th. Just the sine function is to the 5th. So I was looking at it wrong. So this sine function here is going to be my inside function because it's raised to the 5th power. So when I write u as sine 3t minus t cubed, I have to take the derivative. So remember I said derivative. So the derivative of sine is cosine, and that's 3t, and you have to then take the derivative of the inside function, which is 3. Then the second term is to take the derivative of the minus t cubed, so that's 3t squared. Now, if you're like, oh, what did we do here? We applied the chain rule. So because this is a composition, you had to pull the 3 on the outside. Now, if you look at this, the cosine of 3t is here, but this 3 on the outside's not. Well, the t squared is here, but the 3 is not. So we have a multiple of 3 that we can pull out. And when we think about that, that means that leaves us with a 1/3. So that'll be 1/3. And then that takes care of the 3. And then the cosine 3t minus t squared and the dt are taken care of with du. So here. And then this sine, this here to the 5th is u to the 5th. So now I say I want to take the antiderivative of u to the 5th. So that's u to the 6th divided by 6 plus c. Now, looking here, you're going to want to do something with the 1/3 and 6. You can either make the 18 in the denominator here, or you can pull out 1 over 18 u to the 6th. So what I did is I pulled out the 1 over 18 u to the 6th, and then it looks something like this. Now, like I said, you could have had your sine 3t minus t cubed all to the 6th power divided by 18. and then the plus C on the outside. I was feeling like pulling my 1/18 to the out, and that's fine. The algebra of this is not what I'm concerned about. I'm more concerned about taking the antiderivative, being able to pull out your u, determine your du, do the manipulation, like we did here, pulling out the 1/3. Okay, so I know this is was kind of quick, but we will do more problems next class, and if I have to record a video for that, I will, and we'll go from there. Y'all have a great rest of your day, and reach out if you need anything at all.